So we will try to do a rough overview of how one actually contributes. If we welcome to do as much as you can, but if you can't, I would just take it in and hopefully we'll communicate the steps through enough osmosis that other people can support each other. As you saw, there's issues with doing this, but let's just get through what we can and see what we can do. As usual, these slides are up. You don't even need, you can just remove the HTML page and there's a top page that will let you select this section, which is contributing. Maybe I'll show that very quickly. So yeah, it's tiny print. It wasn't meant to be read, but you can go in there and pick the website there. So if you just want to type in myname.org/mom6workshop, that'll take you there. If anyone would like me to leave that up, I can, but otherwise, I think I'm going to move on. Yes, we use GitHub to house our repository. We have signed on to Team Microsoft here, and we track our code through GitHub. This is a bit of a tour. This is not the MOM6 examples repository. This is the MOM6 repository. So as I mentioned last week, MOM6 examples is really more of a monorepo, and it contains several submodules, one of which is the actual MOM6 code. So this is where all the magic happens, and all the other stuff is a wrapper to do general operations. So if you've been looking at the MOM6 examples page, it's pretty much the same. I will not do a big tour of this now. We can come back to it as we get into the business. But how do I go back? So, but that is there. If you click that picture, if you have it up on your browser, it's just a link to the page. So this is represents all the activity at GFDL. So I'm assuming everyone here is pretty much going to be working through GFDL. So any work you guys do that you contribute is going to go through this repository, NOAA GFDL MOM6. And the reason I'm banging on about that is that there is a macro repository. We are one of many MOM6 repositories. We are, I don't know if consortium is what we call it, but we are a kind of consortium. We are this blue bubble here, the NOAA GFDL bubble. And so the idea is that there are many collaborators to MOM6. And of course, there are some that are more active than others. But in principle, we are this federation of teams that are all contributing. And the idea is that each one of these inner hub circles is a lab that does do production runs, needs fidelity of their experiments, needs to preserve their code base, and needs reproducibility. And so we get contributions from these other groups, but formally the way we do it is that NOAA GFDL, for example, will make some code changes, sometimes a lot of code changes, and that will happen through this little circle here. So each of these nodes may have tons of users, such as everyone in this room, who would be the small circles. And they would do their code, they would send their pull requests up to NOAA GFDL, and they would get approved. And then eventually, those codes go through a much more formal process where NOAA GFDL submits its changes to MOM-Ocean, which is the principal, the public-facing website of MOM6, beyond the NOAA GFDL government bubble and the big true, quote, open source MOM6. And so that's a very formal process. Everybody, well, it varies, but not everybody in this circle at the moment, but technically 6 of these 8 have to, we require 6 of the 8 groups to approve any contribution that goes into MOM-Ocean. So if we make something and it breaks NCAR's runs, they can just say, no, we don't like it, we don't want it, and there's nothing we can do about it. We actually have a pretty formal process in the code where we need 5 approval buttons to be clicked before any code can go in. But it's very fun. This is just to show you, of course, it looks very similar, but one thing is it's missing this little tag at the button saying forked from so-and-so. The progress question here, I think I'll just pull one up quickly. We'll get into all the details, but I just want to show that these are rather formal. I mean, there's no lawyers involved, but these can be rather formal. We sort of detail all the contributions we've done over a period. I guess I do. I have a script that generates all this. I don't work that hard. but a lot of code. And when we get down here, we have these discussions where people say they verify it in their own runs. This is Florida State co-ops approving it. This is EMC approving it. And again, NCAR is approving it. This is NASA GEOS approving it. And so it's fun. But the point is, as individuals, you probably shouldn't expect to interact with MomOcean. If you have changes you want to make to the code, you should not send them to MomOcean. And by the way, we all do it all the time. We all accidentally send it to MomOcean. And then we have to, oops, and then we close it. But if you guys have contributions, you really want to go through the NOAA GFDL repository. And so, I mean, an implicit message here I'm getting across is that there are many MOM6 repositories, and you have to be specific on which one you interact with in your Git. So I'm going to, yeah. Well, technically, each international contributor, in some circumstances, they will be an equal partner. So, for example, we have KIOS, South Korea's oceanography department, and then we have Access, which is Australia. At the moment, we sort of structure them as equal partners, although neither of them has actually contributed yet, so they don't really participate in that process yet. But there are two options. One is to declare yourself an equal partner. There's no paperwork. It's not a formal thing. It's just whether we want it to be. And it's very open at the moment. The other option is you choose one of these bubbles. So if you're in another country, doesn't have a formal relationship, doesn't know anybody who works on MOM6, you'll go through NOAA GFDL. I am, yeah, I'm talking about a user as well. Yeah. And yeah, that's right. Yeah, I mean, of course, you know, it's natural that NOAA GFDL would take on the bulk of that responsibility. But I mean, I think the idea, it's a question that's unanswered in my opinion. In practice, we tend to funnel everything through NOAA GFDL. Does that answer it? Okay. But it's a good question though, because it's also something I'd like to see formalized. Yeah, like actually we have people that send patches to EMC. I've sent patches to NCAR that then, you know, just because I work here doesn't mean I have to send them to NOAA GFDL. Yeah. Oh, it's another very good question, one that's still lacking formality. We have proposed monthly updates, at least from us, because we're so busy here. The other groups, the issue is every time we submit a change to MomOcean, we're also putting a big pile of work on everybody's plate. They have to go and run their production runs. They have to verify that everything's working. So if we did it every week or even, you know, even every day, that we would lose partners pretty quickly. So I think we aim for a month. In practice, it's several months. But I mean, I think it's another one of those places where we could do better. We could think about it. But I think the truth is at the moment, we're not that busy. It's not, you know, a lot of these issues, we're raising them before they're real issues. But I think the time will come when we have to think about, well, I hope that becomes a problem because that means we've been successful beyond our capacity. So yeah, to answer your question, it should be relatively infrequent, that it's not a burden on everyone, but frequent enough that people want stuff. And by the way, because of I'm not going to go over the process, but we do things in such a way that permits sharing within the inner spoke. So for example, if GFDL gets a fix out quite quickly that is needed by NCAR or EMC, they can take that right away. And we have set things up such that there won't be any conflicts in the history and that will not create an issue for anyone else. So yeah, I mean, we're pretty comfortable with this layout. I think it's gonna scale quite well because the questions are very obvious, even if the answers aren't. Yeah, so I think we're going to do a little exercise now. So everybody's probably already cloned mom6 examples, but I would like everyone to go in a separate directory completely and clone mom6. So is everyone ready to start tapping away and give that a try? Okay. So I'll leave this up for a little bit and then I'll flip to the terminal and I'll do it. If you guys all have browsers open with this, that will be very helpful because I only got one screen. So one thing I'll note, don't forget the recursive. As I mentioned before, we do have submodules in mom6, that is CVMix and TOS with GSW. If you forget it, it's actually constructive to forget it because you'll see the error that always happens, which is it can't find CVMix. So I'm going to flip over now. Try to use this terrible keyboard. While this is running, I'll say that I imagine a lot of you have been exposed to Git already and have been using it. So even though a lot of these concepts will probably be familiar, what I'm going to do is not so much focused on using Git for version control, but Git for collaboration. And I think that while a lot of the commands will be the same, I'm hoping the emphasis will be on things that maybe are not so much emphasized in your first introduction tutorial to Git. So here we are here. And if you have that slide up, I recommended doing this. So looking at remotes. Now, has anyone, oh, we got to go in it. Now, if I'm talking about remotes, who here how many people know what I'm talking about when I talk about a Git remote? And how many people don't? Okay, so hands on, okay, 50-50, great. So remember that figure I showed with all those bubbles? Remotes are how we connect our personal version to all the many versions out there. So Git is a distributed version control system. And as we saw, there are many mom6s. And so we need a method to communicate not with the repository, but all the repositories, or at least the ones we care about. So when I do git remote -v, it has created a remote called origin, and it's got the URL for the NOAA mom6. So that's what I wanted to show. Now, the exercise here, I'm going to do it with you guys. We're going to step through it. It's a lot of clicking. It's not a lot of typing. But what I want people to do is make a new remote for their personal fork. Now, is everybody logged into GitHub and has it up? So let us go there. Let's go to this one. Yeah, you can click on the picture of the, you know what, I'll do it. I'll do it so we all do it together. So let's click the picture. Oh, I don't want to lose my page. How do I do it in a new tab? Can I shift click or something? Nope, that didn't do it. I'm going to, oh, control click, there we go. Okay, so you notice this has this little thing. NOAA GFDL mom6 is a fork from MomOcean. That's sort of illustrating the hierarchy. NOAA GFDL is derivative of MomOcean. Now, now most of you probably have already done this, but if you click fork, you can, ooh, I'm logged in as you, Alistair. Use the, oh, all right. Yeah, I'll find it.
Down here, down here.
Where?
Yeah, was it that one there?
Oh, got it.
That's you.
Sorry, guys. Hope you don't mind all this. All right, so we're here, and I'm going to click fork. And that's my old job. That shouldn't be there. Okay, so what you do is I click this button fork here, and it's taking me to a page to create a new fork. And as you see, I've already done it. So, but if you click the owner tab here, there'll be some options. If you're a member of any groups, you'll be able to do it. These are all these great groups I'm a member of. I created half of them. Is everyone fine with that? And then the name, we'll keep the name mom6. These are just little details. We're just going to copy the dev GFDL branch. I'll get into that. So is everyone up to here, and has everyone been able to create the fork? If anyone has not, now's your chance. It's just a bunch of clicking, so I'm hoping it's okay. All right, so let's assume that worked. And what that means is I'm going to type it in, but you guys will probably, if you haven't done it yet, it'll probably just pop right up for you. Now, is everyone on their personal fork? Okay. Now, what you want to do is create a remote, and I want you to do it from the command line, not any kind of clicky tools. So where does it let you get the URL? Oh, thank you. Yeah, you can tell I don't ever do this. Okay, so that lets you copy and paste the URL. And yeah, I'll be honest, guys, I never use SSH. If people are having trouble with their SSH keys, no. Yeah. Yeah, I would say if you guys know what you're doing, do the SSH. But if you don't have SSH keys set up, it's just going to cause problems. Use HTTPS and let's see how far we get. This was the very issue Alistair was trying to inoculate us from. So I'm going to use HTTPS because I'm a cool kid and I know how to do everything with HTTPS. And if you guys want to learn how, you can ask me later. Now we are back in the terminal. And we are going to create a new terminal, a new remote. Git remote add. And I'm going to name mine after me. This is the name you pick. This is your personal reference. This is a little short word that you use to access this new repository, which is your personal one. Now, and then put the URL. So I have done it. That's right. Inside your new mom6 directory. Now, if I do git remote -v again, I will see that I have two remotes. So now I can communicate with both of those forks. It's your choice. I would be flattered. I would be flattered if you chose my name for your fork. However, that's probably not a good way to remember it. This is literally a name you choose to reference it. You can call it me. You can call it Matthew. You know. That's right. In fact, why don't we all do that just for fun? No, if you want. But sorry, did I misunderstand the question? What was the question? But what? All right. All right. So now we have a remote, and I think that is one of those sort of collaborating concepts that do kind of get lost if you're going through a kind of initial tutorial. So I have too many browsers. It means you have a connection now to a second version of mom6. So now if you want to make changes, you don't have to send them to the official NOAA version or the MomOcean version. You're going to work and send them to your private version. It's distributed. So Git is distributed, and as a result, your work has no chance of ruining everyone else's work. Yeah? Cloning from NOAA GFDL, you mean? Cloning your own fork? Oh, okay. You could have done that. Yeah, you know what? You could have done that as well. Yeah, I understand. I guess that would be how it would be normally introduced in a tutorial. I'm trying to show you how to look at it from a different way, because what's going to happen is if you get into this lifestyle, you're going to work with somebody else, and you're going to need to make, you're going to collaborate with someone. They're going to have changes, or you're going to want to give them changes, and you're not going to clone their repository. You're going to keep your repository, create a remote to that third one, and then you guys will be sending code back and forth through that remote. So that's why I'm going through it this way. Yeah, thanks. I'm sorry I misunderstood the question. Oh, good. Oh, did I? Oh, no. I'll explain that. Sorry. That's right. Yeah. Yeah. I'm glad you called that out. That's actually a historical artifact. What is MomOcean now used to be Noah GFDL. So when I forked this, it said no from Noah GFDL there. But when we created that consortium, we literally changed the name of MomOcean. We literally changed the name of MomOcean to Noah GFDL, from Noah GFDL to MomOcean, and then created a brand new Noah GFDL. So if I was a good Git citizen, I would delete this repository and create a whole new fork. But I've been so bad about it. But yes, that's why that says that there. But great, that's how it should be. Yeah, I wish I was that good. Alistair's done it. Bob and I have not, for example. Or maybe Bob has done it now. Have you? No. Yeah. It's actually the yeah. Yeah, I mean, the truth is, as we'll get to in a minute, you can bring it all in sync. You can get all the information from Noah GFDL into yours, even though you forked from MomOcean. That is gone. The only real thing here is that when you create a new pull request, it assumes you want to send it to MomOcean. So the default behavior is terrible. And it's really the only consequence of that decision. But it's also why I accidentally send things to MomOcean all the time.
There's one other consequence, which is that sync fork button, which is on the screen. That's going to only sync with MomOcean. So if you want to work with GFDL, you won't get automatic reminders to sync GFDL. That's the other downside.
That button looks horrible. Don't ever click that. I don't know why GitHub is a crazy company. They try to make everything so dumb. Anyway, so we've gone over this. Everybody should be caught up. So there is one step here that actually there's no real point in doing this final step, but it's a nice introduction to the next point. So we have created a fork of Noah GFDL. I'm going to show you, we have a branch called dev-GFDL. That's the same as the branch, the principal branch at Noah GFDL. I'm going to type this out. You'll see nothing will happen because we've already, oh, why did something happen? I'm not sure yet. I'm very confused that anything even happened there. Does anyone know why? But why? Did Bob merge something before I? Okay, you know what? I'm glad I did it. This is exactly why you should do it. But let's talk about what I actually did there. So this is the next concept that you probably want to get comfortable with, which is branching. So branches are like snapshots of the code. So again, I'm going to ask the same question I asked with remotes. How many people are familiar with branches? Yeah. Okay. Okay. So how many are, so about how, and how many of you have never heard of branches? Okay, a small number, but that's good. So I won't talk too much about it then, but so branching, although are snapshots of the code, and the idea is that they allow you to work on things without screwing with the version you care about. So there's a branch called dev-GFDL, which exists on Noah GFDL and your personal fork and your private laptop. Those are all 3 repositories now, 2 connected by internet, but there are 3. And they're all equal, they all have equal status. So what we are going to do is first, we're going to do git pull, which takes that version from dev-GFDL. Origin is the default, by the way. So the origin remote, we're going to pull from that and sync what we have. So suppose we want to do something new. We want to get the latest version of dev.gfdl, which is the main branch on Noah GFDL, before we do anything. We don't want to start working on an out-of-date version of the code. So we're going to, now, these are my branches. I'm going to check out dev.gfdl, even though I'm already there. But luckily, the tool's there to tell me I'm wasting my time. So git checkout is how you switch between branches. We only have one branch at the moment, but we are going to do a new feature. So I'm going to do -B to make a new branch that doesn't exist. And I call it my feature on here, I guess. Alistair told me that's a terrible name, but I didn't get to update the slides. But we have a new branch called my feature. Now, if I do git branch, I see 2 branches. And so now I can manipulate the code in any way I want, and I don't have to worry about changing dev.gfdl. But I do know that at the moment, it's a perfect copy of the main GFDL branch. Now, if I must, thank you. Yep, and nothing came up, so not interesting. But thank you. That's actually a good advice, because you will be surprised how often things are not the way you think they are. And I kind of do git diffs kind of frantically, mostly because a lot of my time is spent updating dev.gfdl and I don't want to break anything. But yeah, I don't know if I get to that later, but thank you for suggesting it. So we are now going to change something. So if we had had time to do the exercise, we could have done that. We're going to do, I have an example here, by the way, if you want to see how I added a diagnostic. But we're not going to do that. So we're going to do the stupidest patch you can imagine. We're going to add a little welcome message to the model. Because that's what we need, more garbage in the output, right? So I wrote this as a diff file. This is what you would get from the git diff command that Bob suggested. You're willing to make any change you want, by the way. So we're going to go to the terminal. And I imagine time must be going real slowly, right? Okay, are we already done with session 1? Okay, then we have no hope of getting through, which I was prepared for. So this part, keep up with it to the best of your ability. I'm going to go in and edit the code. As I said, it really doesn't matter what you do in this next part, but I'm going to look for the initialize mom function. I am in file source core mom.f90. Use your editor of choice, as long as it's Vim. I'm going to do a search for initialize mom. This is not my normal environment. I apologize. Why can't, oh, because it's not my normal Vim. Got it. So, wow. Okay, I'm gonna have to do this in a very scattered way. I apologize. This isn't my machine. But if you're not stuck like me, you're going to look for the initialize mom function, and then you're going to okay, this is where it starts. It's line 1912, which shows you how big these files are. And we're going to write a message here. Now, I don't care if you would people like a little more time to? Sure. Yeah. In this case, yes, we're not going to deal with that, but thank you. I don't want to confuse things. Yeah. Yes, yes. Okay. This is a terrible way to do parallel output. Yeah, but no, there's not. We're not talking about that. But thank you. Yes. So I'm happy to leave this up. I'm happy to move on. We are kind of short on time, so But the idea is it doesn't even have to be what I did. You can go in and add some space to a line. It's really almost irrelevant. Now, there are two commands that we use to kind of check things. So git diff, as Bob mentioned, would tell us exactly the change we made. So now this is what we call an unstaged change. This is where your traditional Git education would kick in. This is a change of the code, but it has not yet been staged to put in the repository. So this is one of those Git concepts where they separate that, unlike things like Subversion, where it's all mashed together. So the other command here that I use a lot religiously is git status. This does not show all the changes you made. It just shows the list of files that were changed. Often I will see diffs that are many thousands of lines across dozens of files. So diff is not always what I want. Git status is how I see. And so so if you go to the slides, I put an example of this. I had it for a different file, but you know, it's the same idea. Now, if I go back, now what we want to do is git add the file. So do people want to follow along with that? I think I will skip through that part pretty quickly. Now, if I do git status, it shows, well, in my case, it's green. If you didn't have colors, you would see changes to be committed, and then you would see changes not staged for commit. And so that was that. So colors are nice, but if you don't have them, you can look for those two sections. So, but the point is now the file is ready to be committed. Oh. Yeah, so git add did that. A lot of times you'll find people do, you know what, I'll skip to that in a minute. Yeah. So now we're going to commit the change. Yes, Bob? Yes. Although it actually may be useful if we put a bad commit, but we have a system to catch it. But yes, so I'm going to create commit. And again, this might deviate from your education. We're just typing git commit and nothing else. So in my case, it opens up an editor in Nano. And so on the first line, I have an example here. And you see I have a line here that is the subject, and then I have a blank line, and then I have the content. And then I have a bunch of stuff after that, which is not going to be part of the commit message. So a welcome message. This is a welcome message to welcome new people. Now, I mean, how do I do this in control? Yes, yes. I will show you. So I write it, and then I quit. Now, where did that message go? Type git log, and you see it. And you see that we have created a new commit, and it has a message. And it has a subject and a body. Excuse me? Git log one line. Yeah, but that's another way to span many. Now, would anyone like me to pause? Control X, Control O to write, Control X to quit. Yeah, when you guys go home, you might want to configure your Git editor. You might want to look up how to do that. I don't want to do it here. What's that? You're lucky. One way to do it is to set the editor environment variable. I don't know. I think that'll work. There's many ways to do it. You actually want to do it inside Git. probably. But I really don't want to lose time on that. All right, so I showed it in the log and we have it. And so locally, we have created a brand new version of MOM. But of course, none of the remotes are aware of it. It's very much restricted to our personal repository. But the comment I want to make is that when people learn Git, they're usually taught to use this -m flag. Now, how many use -m when they type git commit? Okay. Okay, you're all bad people. Yeah. Okay, so that is how you do a one-line commit. And it's the biggest plague on Git that's propagated through the entire world. And it's terribly disappointing because if you look at the history of Git, Git was actually written to emulate the Linux development process. It was made by Linus Torvalds, who also made initiated Linux. And in Linux, before Git existed, the way you would update your software is you would create a patch using the Linux diff, the Unix diff program. That would create that funny looking file that shows up when I type git diff. Then you would attach that to an email, and in your email, you would put a subject, and then you would put a body in your email describing what you had just done. So you'd have a genuine form of communication that you use to talk to the other people that you had written. You didn't just write one line in your subject and then mail it off and expect everybody to know what to do with it. So the point is that when you write commit logs, they're really supposed to be, think of them as emails. Now, of course, times have moved on, but what I would say is that the line I wrote here is the closer you follow these rules, the better the results. It means that there'll be a much better history of what you did. Things like git log will be sensible and readable. And overall, in general, the Git tool chain is going to understand what's going on a lot better. There are ways to generate patches. There are ways to generate all sorts of supplemental output and do interesting things. But if you just write little cruddy -m messages, the output is going to be pretty useless for a lot of people. And I have a quote that I love to get from, that I love to tell everybody, from Linus Torvalds about 2 years ago. He was in a nice Q&A, and they were asking him about what it's like to juggle thousands and thousands of pull requests. Well, they don't call them pull requests. They don't use GitHub, by the way. They think it's stupid. Yes, it's true. No, Linus is not paid by GitHub. He's paid by the Linux Foundation. I did. I got $550 from GitHub. I'll tell that story someday. I think it was a mistake on their part, but I'll come back to that. Oh, yeah. No, that was before I became a... Yeah, so the quote here is, commit messages to me are almost as important as the code change itself. If you can explain the code change to me, I will trust the code. It's his way of saying that if you don't know what you did, if you can't say the change you made, you probably don't understand it. And why in the world would he trust what you did if you're not going to even bother explaining what you did? So if you go to our repository and you look at our Git log, we have very long commit changes. You know, here's one from He Wang. He has a subject explaining the new self-attraction and loading feature. He explains what he did and he explains in detail. So when I see this, I don't have to go guessing, because the actual change is quite large and it's all over the place and it's spread across 7 files. And maybe this one's not that big, but the point is, how am I supposed to know what he did? Well, first I read the log and see why he did it. And again, he broke it up into multiple commits. I'll get to that in a minute. I'm looking for one of Bob's really eloquent ones. Yeah, here's a Bob one. So, I mean, you know, it's like, you know, it's a very detailed explanation of what's going on here. And I know Bob's dying to explain this final sentence, but I think we will move on. But, and here's one of mine, obviously beautiful. But the point is that these are kind of like, this is like a running diary of the evolution of the code. And to me, I mean, as academics, you guys should care about that. This is like your paper trail. This is your careers. So, I mean, you're not going to get citations or promotions over it, but, you know, have a paper trail. So, moving on. So now, again, as I said, we've done everything locally. We haven't shared anything. So now we're going to communicate it. And I've set this up to go to the personal fork. So yeah, I'm fine with this. You can tell this is still a bit of an in-process thing. So I will keep those up. Hopefully you guys can access them on your browsers. That's right. And this is the step that's not going to work. There's a warning about CESM. Can I close it? I did. All right. So first step I'm going to do is I did a bunch of work, but the thing to keep in mind is DevGFDL was not static while you were doing that. That was a lot of work putting that welcome message in there. And it probably took weeks and weeks to finish. And in the meantime, who knows how many changes Bob made to the code in that. So my DevGFDL has changed since you did that. So what we're going to do is we're going to fetch origin. Now, nothing happened because nothing's happened. But what that would do is that would resync the Noah GFDL repository that I would have. Now, I'm going to check out. OK, I'm not going to. All right, so looking at my branches, I'm going to do it anyway, but I'm going to check out my feature, even though I'm already there. And now I'm going to do something called a rebase. So this is where I take my contribution and I reorganize it relative to the new status of DevGFDL. So when you do that, a little menu pops up here. Oh, by the way, that editor trick I did actually work because I'm now in Vim. So what's this done is if I had had multiple commits here, it would have shown me all the changes that I have personally made since I've forked off from DevGFDL. But it's also not showing me all the changes that happened at DevGFDL after I started. But what it's doing is it's giving me an opportunity to go through all my personal commits that I made and reorganize them. I can change the order, although that can create issues, so generally you don't want to change the order. But one thing I can do is, I know this color is not great. Did you suggest, what did you suggest? Evening. Well, it's better. No, it's better. P is just sort of standard pick. It just preserves it. You can change the name of the commit messages. You can change the name of the commit log. You can squash, which is a way of taking multiple commits and smashing them together. You can delete commits. I've done that before. So it's a way of kind of saying, I did this work, but now it's time for me to reorganize it and prepare it. Now, this is such a silly example that I don't need to do anything. But if I quit, so this was successful. What you often find is it can be, I'm going to get into the challenges that can happen there. But my point here is to say that if you want to rebase, fine. If you don't want to rebase, if you find that too weird and scary, that's fine too. But my main message here is just because you've finished, just because you've put all your commits in, you're still not done. You still need to recalibrate all your work with how DevGFDL has changed since you've been away. So moving on, the other comment I want to make is minor commits. So suppose you were working on it and you spelled mom wrong. You wrote welcome to Mo. In fact, let's do that. So let's go to source. Actually, I forgot an exclamation point. Big deal, right? So I'm going to put an exclamation point. Welcome to Mom, or Mom6. That's what I should do. Because the 6 is very important. Now I'm going to, what? Did I? No, I didn't. No, I turned it to a 6. Yeah, you're skeptical. There. Now I'm going to do something you should never do. So I'm going to do -A, which automatically adds all the files for you. That's often what people are exposed to on their first exposure to Git. The reason I generally don't think you should do that is because you should be in control. You should know what you're adding. You're going to get to a point where you're manipulating files that you don't want to commit. You're still working on them. So you probably want to manually add them. But I'm going to do the other dreaded -M. Forgot the 6. Oh, really? Okay, it worked. Um, that was the thing Alistair was talking about. The dash A automatically added the file. It automatically did the git add. So instead of the dash A, I could have done the git add source core mom6 again. Now I've done this stupid commit here. Nobody needs to know this. Now, nobody needed the first part. But the point is that these two commits really kind of don't serve any kind of like that second commit is just you kind of not doing your job. You forgot something, it's your fault, and now you're burdening the rest of the world with this commit that adds no content. So instead, don't do this step, by the way. Don't worry about this. I'm going to reset. So I'm going to undo that commit. Don't worry about that step. I'm just doing that to demonstrate. Now, instead of adding a whole new commit for that one typo, what I can do is, well, I'm going to not use the dash A. Instead, I'm going to do an amend commit. So what this is doing is instead of adding a new commit, it's modifying the most recent commit. So you can see the old message is there, the old log is there, and we're done. So what we've done is literally changed our repository. So that old commit is dead, and it's now the new commit. So the point is that this is showing your response. This is showing your responsible usage of the repository. So these commits, now what happens is when you're doing development, you don't need to worry about this. If you're trying to add something, you can say, trying this, adding this, doing this, use the -m flag all you want. That's great. That's called development. We all make mistakes, except me. And then we're going to keep working on it. But when you're done, you got to go back and clean up your commits. Well, we would request it, I should say. Now, if you go back and look through the history of the model, that's not always happening. Some of the other nodes don't do that. We don't try to tell people how to run their store. So if we respect that, we have to. That comes back to how we maintain histories. We have to honor the histories of all the nodes. So if one of the other nodes does put in commits we don't like, there's nothing we can do. We respect that history. But in our house, you follow our rules. And in our house, we don't like garbage commits. Do that in your house. And so git commit amend is a simple way. Another thing we could have done is the rebase. I could have done something called squash. I could have taken multiple commits and combined them into a new commit. It would have been literally the same as this. So that's the message I want to get across there. And now we're ready to submit. Now, did I put slides on this? Okay, I'm sorry, I don't have slides. You're gonna have to follow me typing for this next part. So we have our new commit. Don't follow me quite yet. All right, now I'm going to push. Now we're going to use the push command. I apologize. Okay. Now I'm going to push not to know a GFDL because that's not ours. That's the community one. Well, that's the GFDL community one. And we're going to push to our personal one. Now, if it's me or Matthew, you type Marshall. Everyone else, you use whatever name you put. Now, mine got rejected, and that's a pretty good example. If you guys are following along, yours probably was not rejected. The reason mine was rejected was because I did a commit amend. I changed my history. My hashes here no longer aligned with my hashes over there. So this is something you do with great caution because this is something that will wipe out work you may have done. But you can do what's called a force push. That's right. That's right. And if you don't have access, forget any of this. But thank you for that reminder. But now we're going to go back to clicky land. So if we go back, oh, I have a tab for that, right? This one. So now if you go here, it says my feature had recent pushes less than a minute ago. Now this button appears after you push something, and then after some time, an hour, it goes away. So maybe I will show how to do this without that button. But what I can do is go to pull requests and go to new pull request. Now I want to choose a branch, and I'm going to choose I have a lot of branches, don't I? Because I'm so productive. And now we want to send it somewhere. Now, as I mentioned, I'm configured to go to main, which is a bad idea. We don't do that. So I'm going to switch to NOAA GFDL MOM6. So if you can see this little arrow here, it's indicating that we're going from my personal fork to another repository. And I don't want to go to the main branch. I want to go to dev.gfdl because I didn't explain that main branch, but that's not our branch. That's a copy of the MOM-Ocean branch. If I do this, you see there's a nice little graphical depiction of the change. This is pretty easy to navigate, I think, given what it is. MOM6 user, is that me? Okay, normally this would be configured. I think Alistair set me up so I would be able to do this on his computer. But normally that would appear as your GitHub username, I guess. Yeah, I think the problem is my local repository doesn't understand that I exist as Marshall Ward. Oh, actually, no, I won't do it because it will. I don't know. Should I do it? All right. All right. So yeah, I'm going to do it. All right. So now, so you notice if you have one commit, this is quite nice. It takes your subject from your commit log and the body from your commit and puts it in here. So it turns the commit into a pull request message. And this is a good example of what I was saying before. If you follow the Git, if you think of the commit log as an email, everything just works better. So, yeah, what does this do? No. Yes, but there are safeguards. So yes, I think that discipline is essential, but in fact, for those that fail it, there are things that will come up that will stop it. So I'm going to create it. Bob's going to reject it. So now we have this, and I'm going to write a message. What are you, Halver? Can you please review? Do you have internet, Bob? Can you do it right now? Yeah, good idea. Actually, we don't do this enough. So yeah, we don't do this enough, but you can actually assign reviewers, and I think we could all do that a little more. It would help expedite. But yeah, another thing that I like is the Git commits appear here, and if you click these dots, you'll see the message there. So anyway, what's happening here now is it's triggering the first stage of our testing. So what this is our automatic testing, which I'm going to talk a little bit more about in the next bundle of slides. But yeah, so this is one of the safeguards that prevents bad code from getting in. We have another more serious one. It's testing it on what we'll call GitHub Actions. It's a bunch of machines that Microsoft runs. It's the Azure cloud. In fact, I'm being so vague and circuitous because it doesn't matter. It's running somewhere else. Exactly. Yes. That's the world we live in now. Welcome to cloud computing. John was first. Well, it's a very difficult question, and it's one we talk about a fair bit. I mean, I think the worst part is people don't ask the question. And for me, I'm happy. If people are even thinking about it, I consider that an incredible victory. So the details around what you're saying, certainly, I think Bob says that every commit should pass our tests. And I think that's a good policy. And I even someday would like to enforce that. But it's tricky to do in practice, and I'm not sure we want to do it quite yet anyway. But I think this is always the fallback cop-out answer, but it's the community's decision. But in my opinion, they should be small enough that they are doing something of substance, because almost the fact that if you can write a paragraph about it, it's probably doing something meaningful. If you need to write 10 paragraphs about it, it's probably doing too much. Breaking them up is important because I'm not going to talk about this, but if you want to debug a problem, it may not have been found until months, if not years later. And you don't want to have to check a massive commit to see one little bug that happens. So splitting your commits into smaller, splitting your work into smaller commits allows you to do something called a git bisect, which lets you kind of logarithmically step through the entire history of the model, in fact. And, you know, I mean, I don't know if you guys know this, but if you search bisection through any list or like a search or something, it's very fast, you know, log time. So, yeah. Right. Yeah, you don't want broken commits. Exactly. Yeah, you don't want to do half a function and then put it in a commit because you got tired. That commit should be functional. Nor. Yes, and I think it's I think it's already happening. I think you don't have to do anything on your end. I think what our repository has the configuration file in it. So once you fork it, and if you change your fork, that file has already triggered the testing. The exceptions are, we don't do what we call the regression test. It's not a formal regression. It's a comparison to deb-GFDL, or comparison to what it's being merged into, excuse me. But pretty much the tests do run on their own. Well, if they're working, no. I put some changes in where it's supposed to only detect the removal of diagnostics, not the introduction of diagnostics. I think we found edge cases where that fails, though. You might have, maybe you're asking because that happened to you. Yes. And I think I mean, this is getting into a separate topic, but I think we do want that to be considered a fail, reordering. This is because we document parameters. Have you rejected this yet, Bob? Oh, this proposed change is a terrible idea and that it will lead to numerous messages. Yes. Thank you, Bob. Thank you. Oh, I won't do it. Okay, so this was a terrible idea. Thank you. So I'm going to close with comment. All right. I mean, the testing is not really well demonstrated here. So, all right, I will briefly go over these. They are still running, by the way. It's not cheap. So this first test, I'm going to start from the bottom and go up because that seems to be the order that they're reporting them. So this test goes through our documentation. I mentioned that we put document strings around in critical parts of the model. If any are missing, and this catches them, it's not perfect, but it will reject this. It will report a fail. The code coverage test is actually, I think, mislabeled. I think it does a bit more than that, but we have an application that detects what parts of the model we're actually testing. It's shamefully low at the moment. It's like 35, 40%, but we do have plans to have a thing where every single line is at least exercised. It's what you would call a necessary but not sufficient condition for quality. This test tests all the drivers that I talked about in the morning. Stencils, these do tests that I will explain later. I think we'll look inside this one actually, just to show what's happening. So this is a bunch of GitHub stuff, not interesting. Same with this. This is something we wrote, but this just sets up the node. It basically it does what you guys all had to do yesterday morning. It installs all the necessary packages that people need. Sorry about that. Equally, this builds FMS, I think. We don't need to get into it. This compiles the model. What does this do? Oh, this runs the model. So this is actually the first part of the test. So these done's labels mean, so we have a bunch of tests. I will maybe explain later. I suspect I'm not going to have time, but we have a bunch of little micro tests that we run. They're in this .testing directory. They're meant to be very small. They're not meant to be realistic. They're meant to fit on these Azure cloud nodes. And this first wave runs through all the tests. It runs through multiple compiled versions. It runs through multiple configurations, and it just makes sure that it didn't die. So if any of them don't work, we're done. The test is reported as rejected. Why did these get in here? This must be a mistake. Oh no, these are your run tests. You made these. Okay, I apologize. There's a lot more tests in here. And in fact, this actually shows that there's a done, which means it ran, and then there's a pass. This is, I will get into in the next group of slides, but this is where we check the output and make sure that it's all correct. Essentially, it's a bunch of A/B tests. We run the model in one configuration, we run it in another, we make sure the answers are identical. And then the rest is boring. But that's basically the nature of the tests. I hope I captured everything you wanted me to show, Alistair, at least at this stage. But yeah, that was a big bust. Bob rejected my pull request. But yeah, we're good. That's gone. That was a great exercise. Don't do that. We don't want that number getting too high. We don't want it going up to 50. Where are we up to? So I hope that was a good demonstration. Wrong. I'm sorry, not my computer. Now, this is an interesting example. So I had originally put my new diagnostic in, and 2 of my tests had failed, which actually surprised me. And I'm not going to go over why they failed, but it is an opportunity for me to go over the test suite. And I'm going to try to do that here. It's going to take a while, but this is a different way of running the model. We put a little dot in front because even though it's like almost 3 years old, we're still afraid to make it public. But this is the test suite. So that test that GitHub was running for us, you don't need to do that on GitHub. We've set that all up so it runs locally. GitHub actually is doing very little for us in that case. By design, we don't want to be too dependent on them. We used to have all this stuff running on another service called Travis, and we moved it over to GitHub Actions pretty painlessly. And when GitHub Actions betrays us again, like they always do, we'll move it somewhere else. So in this directory, this is the little test that I showed before. So this is using a system called AutoConf, which I'll explain later, but this is doing a bunch of Python, which is not what I want to show you. But this is building everything for us. It's building FMS, it's building MOM, and I will come back to it later. But what it can do is we can run those tests on our end. I think for time, I'm not going to go over the problems I had with that pull request. In the end, they're not important. What's important is that the test can fail. It can catch them. And maybe I can pull it up just to show what a failed test looks like. Now, this is actually an example of your question, Nora, about does it run on its own? So this ran on my personal account without me submitting a pull request. So I'm going to switch to that branch, which I called my, oh, did I clobber it? Oh, that's too bad. But maybe there's a history of it here. Yes, there's a history. So these are not my tests. Yeah, yeah, I don't know why. Really? Okay, well then, let's just say, oh, there you go. There you go. Yeah, so this one was pretty interesting, I thought. It failed. It failed because I got a floating point exception, and I got a trace back. And the reason it failed was in my OpenMP. So that's the clue. The trace back tells you what line it failed on. And I will say the reason this failed is because in OpenMP, you have to specify the parallels, how it's handled on the threads. And I forgot it because I created a new variable and I didn't add it to the OpenMP. So when I ran it on the OpenMP thread, it didn't know, something got uninitialized and I created an error. So I'm unable to go through all that. I think we're just going to talk about sharing. We're not going to do the other section. But yeah, I think that should take us on here. Oh, and I'll just briefly allude to how the second stage of the testing. So the second stage is not anything to do with GitHub. This is run on our production machine, Gaia, where we do our real work. And so this is demonstrating a very different result, which is that anything we do cannot change the answers of our production runs, of the things that actually matter, the actual business of GFDL. So this is a test. It's actually much bigger than this picture indicates, but what we do is we build many different compilers. This is, there's the ocean only, the sea ice, the fully coupled. That's actually all we build now, isn't it? But we do that on 3 different compilers. So GNU, Intel, and PGI. And then, so it has to work on all of those compilers. And then we run through all those tests, and well, nearly all of those tests in MOM6 examples. And we make sure that answers do not change. Then at least we know it's coming. Right. Yeah. And then you have 2 choices. If it's part is a production run that you want to keep, put the flag in. It'll say something like, keep this little bug. And then flag so that you can reproduce and see them fully published. With the other branch, being if it's something where it's actually bad, like information, then we might just fix the bug. All we know in the commit message, and if you'll notice, someone has to start put that start there or a star in parentheses. We should also say that's a policy we failed to enforce consortium-wide. So it is a good protocol, but it's well, it's a difference between doing it deliberately and accidentally. Like obviously you want to change answers. So you add a new scheme. It's going to be under a flag. By default, it will be off. It won't change any of the old runs. You fix an error in the scheme. We have a process for that. We keep the old scheme. We red light it. We say, this is a bug, turn on the bug flag. We make that the default option. But if you want to fix the bug, you turn on the flag to remove it. And then again, this is one of these amorphous processes, but eventually we flip the default to the proper one. And then eventually we get rid of it. But I mean, the point is that we have a way of always reproducing the old answers for as long as we need. And we're out of time. I'm going to talk about one last concept here with merging. So when you send your pull request, there are actually 3 ways of handling it. So your branch exists on one fork, and it exists, and DevGFDL is on another. You have multiple commits. How do we put them in? We have 3 options available to us. One is called a merge, and that's pretty much a default, although I will note GitHub's is slightly different from the default at the command line. What it does is it creates a merge commit, which is kind of like a way of taking 2 histories and syncing them together through this commit. The reason GitHub does that is because GitHub puts high priority on preserving the integrity of the new branch and the original branch. Everyone's an equal partner. Now, the 2 other options are squashing and rebasing. I discussed rebasing before. Squashing says, well, I know I had all those commits, but forget it. Let's just make a big one. And it mushes them together and makes a new commit. And these first 2 are useful because they don't really change the history of anything. Squash commits happen when we get a pull request from somebody who did something substantive and then added a bunch of those dopey commits that don't add any value. You know, we don't really want to harass people. We just say, thank you very much. We squash them and we put it in. Now, the other option is rebasing, which literally takes all your commits and synthesizes them into the history. It takes them and shifts them to the end of the latest version. And this is a way, we do this a lot, particularly with people who have put a lot of investment in their commits, but we want to sort of preserve the history. So that basically removes them. That changes the commits. That means after we do this, the original branch that they came from is no longer in sync. So that branch is basically dead to us. So it's a way of like preserving linear history, which is amazing for debugging. But the downside is it's quite punishing on the original branch. Now, this is great for someone like me who constantly does everything off a new branch. I never preserve my branches. I assume any development branch I make is trash and is going to go in the garbage once it's merged. There are people who want to preserve the fidelity of their branches, like our partners in the consortium. So we never do a rebase when we go from Noah GFDL to MOM6. We only do merge commits. And I'm sure there are local people who wish I did that more, but generally when merges to Noah GFDL, we try to encourage rebasing so that we have a linear history within our domain. And yeah, this is actually, I'm gonna skip this. Just be aware that when you do things on GitHub, it always creates one of those merge commits. If you do it on your local machine, that doesn't always happen, but it's a topic I don't have time for. Yeah, I had other content I could talk about, but I think it's good that I just picked one and did it well rather than fire hosing the other stuff. The other slides, you can look at them. They're kind of interesting, I guess. But I think I'm done. We talked about how to share. There's a lot I haven't talked about. There's a lot of mistakes to be made still. But I didn't talk about reproducibility, how we ensure floating point reproducibility. Bob alluded to some of the details. I didn't talk about our style guide. I recommend you read it. We actually are pretty fussy on how the code's supposed to look. But other than that, I'm done.
Okay, thank you.